Guys, I have an interesting question to solve from moments. So here we go. So this question says it shows that 7 kilonewton is acting horizontally towards the counterclockwise direction. So since this is acting this way, we should we shouldn't even care about horizontal moment because it's going to be zero, right? Because if some force is acting on horizontally, the horizontal moment is going to be completely zero. So we have to only calculate the vertical. So since this is 4 meter height and 1 meter low, we consider this one is 4 minus 1. What is that? 3. 3 times it's gonna be 3 times 7 kilonewton, and it's clockwise counterclockwise. Therefore, the answer is going to be positive. 3 times 7 is 21 kilonewton meter. Kilonewton meter, and it's clockwise. Yeah, that's our final answer, and it's counterclockwise. This is a mistake right here. It's showing clockwise right here, but the answer is counterclockwise. Therefore, it's positive. Oh. It's not a mistake. It's not a mistake. So if we see from the C direction, top side, if you look at this arrow, if this arrow opposite side, it's going to be going to counterclockwise, right? So since this one is facing toward this side, it means when you imagine, if you turn this one like this, it's going to be turning into clockwise. It's not counterclockwise, it's clockwise. Therefore the answer is negative. And if you put the direction to clockwise, you don't have to write the negative sign. So therefore the answer is 21 kilonewton meter. And let's do one more question right here. Okay, this one. This question have three different forces. Oh, it's four different forces. Four different forces. The first force is acting at 2 meter. So in this case, it's acting vertically. So we shouldn't consider anything about vertical distance or something, because we have to consider the horizontal distance from this is 2 meter. So it's acting clockwise. If you imagine from the top side, it's acting clockwise. So it's negative 2 times 50 uh, plus, and 60 Newton is acting horizontally. So since it's acting horizontally, we shouldn't consider about any horizontal distance or anything about that, only the vertical distance. So since to calculate vertical distance, we use 60 sine 30, 60, and it's actually it's direct to the main point. So therefore doesn't have anything like horizontal or vertical. It doesn't have anything. And if we go to the bottom one, the 20 Newton, we and it's acting horizontally too, but it has a distance. It says it's 3 meter inclined, and it's in the 30-degree incline, right? 30-degree inclined, which means to calculate we forget about the vertical part. Let's calculate the horizontal. So if I made it to the vertical part to make the 20 into a vertical, then only I can calculate the horizontal, right? So to make the 20 Newton acting incline into vertical side, I have to multiply that 20 into sine 30. So it's going to be, and it's acting toward counterclockwise direction, so it's going to be positive counterclockwise direction, and it's positive. Therefore the answer is going to be 20 times 3 sine 30. 3 sine 30, and if you move to the last one, it's 40 Newton downward. So we should forget about any distance or anything about uh, vertical distance. We should forget about that, because if it's acting vertically, we don't have to consider the vertical distance or anything. The only thing we have to calculate is horizontal distance. So from here at the top, we know it's 4 meter plus and 3 meter, and we know the angle is 30-degree inclined. Therefore, the distance is 4 meter plus 3 cos 30 degree plus 2 meter plus 3 cos 30, and it's acting clockwise. So therefore, the answer should be negative and multiply by 40 Newton. So it's minus because it's counterclockwise. I mean minus because it's clockwise, minus clockwise, and 4 meter distance from the top, 4 meter distance from the top, and 3 meter inclined 30-degree. So to make it the inclined part into horizontal, I have to multiply the 40. Um, I have to multiply the 3 meter by cos 30 to make it to the horizontal. So it's gonna be 4 plus, okay, 4 plus 4 plus 3 cos 30, 3 cos 30 multiply by 40 Newton, 40 Newton, right? So this is our total answer. So if we multiply 2 by 50 is minus 100, and 23 sine 30 is equal to 1 over 2. So 3 over 2 multiplied by 20 is going to be 30 plus 30, and minus 3 cos 30 is going to be cos 30 is root 3 by 2, 4 plus 3 root 3 by 2, 4 plus 3 root 3 by 2 multiply by 40 all together, which is going to give me minus 100 plus 30 minus 4 times 4 is going to be 160, minus 160 minus 3 times 4 is 120, root 3 over 2 is 60, root 3 over 2, 60 root 3. So if we add all together, it's going to be minus 70 plus 160 is going to be minus 230 minus 60 root 3. This is our final answer. So we did everything perfect, perfect, and the answer comes out to be negative 334 Newton meter in the clockwise. So if I write negative, I shouldn't write shouldn't draw clockwise direction. If I write it as a positive, I had to draw the clockwise direction, and so the final answer, right? So this is our final answer, and I think that's all we have. Yeah, that's all we have. Maybe I go and do one, like two more. I have some more questions right here. Okay, here we go. Where is that? Yeah, I have, okay, one more question here. So this one is okay. This one is 5 meter distance and 2 meter height, and 100 Newton acting on this one, and it's 5 hypotenuse, 3 opposite, and 4 adjacent. Therefore, let's see what can we do about that. So to find the moment for this, let's say this is what is 2 meter height, 2 meter height, and okay, 2 meter height, 2 meter height and 100 Newton acting on the clockwise direction, therefore it should be negative. And from 2 meter, if I calculate the vertical, if I want to calculate the vertical moment, I have to find the cosine. So in order to find the cosine, what I have to do, I have to multiply this 5 meter. Okay, 5 meter is already there, and 100 times cosine is going to be adjacent over hypotenuse, so 4 over 5. 100 times 4 over 5. 100 times 4 over 5. 4 over 5 times the distance is 5. I have to multiply that one too, plus if I calculate the horizontal moment, it's 2 meter height, and to calculate the horizontal moment I have to multiply 2 meter height, and and it's gonna be a clockwise direction, therefore negative. And 100, to calculate the horizontal side I have to do the sine theta right here. So to do the sine theta, 100 multiplied by 3 over 5. 3 is the opposite side. 3 over 5. 100 multiplied by 3 over 5 times the distance is 2. So 5 times 20 is 100. 20 times 3 is 60. 60 times 2 is 120. This side it's minus 20 times 4 is minus 80. Minus 80 times 5 is minus 400. Minus 400 plus 20 times 3 is 60. 60 times 2 is 120. Minus 120. So the total answer is going to be minus 520. The total answer is minus 120 Newton meter clockwise. So if I write minus, I don't have to show anything. If I write positive, I have to show the clockwise direction. So, oh, wait. Okay, minus 100, 3 over 5. Okay, since we are calculating the vertical direction right here, it's sine theta. So this one is 3 over 5, and this is 4 over 5. So if this is 3 over 5, 300 over 100 minus 20 times 3 is going to be minus minus 20 times 3 is going to be minus 60 times 5 minus 300, and this is 4 over 5 mean 5 times 20 minus 20 times 4 is minus 80. 80 times 2 is 160, minus 160 minus 460 is our answer. 460 clockwise, 460 Newton meter. So that's how we do this one, and I hope you guys enjoy this video. See you next time.